Okay, so you see here we have simultaneous equations in fractions, okay? So some simultaneous equations can be written as fractions, okay? Sometimes you can have the both equations to be as fractions, and sometimes you can have just one of it to be as fraction. So however it is, we just need to do we do the simple thing. And of course, the simple thing we are going to do here we have x over 2 plus y over 3 equals 3, and x plus y over 2 equals 1 and equals 5. So we have to find the value of x and y, right? That's what it means by solving the equation. So this is a fraction, okay? So for us to solve this problem, there are many ways by which we can solve it, but the first, the easier thing to do is to find the LCM, in order to clear the fraction. So we get the LCM. So when we get the LCM of 2, 3, and 1, the LCM of 2, 3, and 1 is 6. Alright, if you have not seen the video on how to find LCM, you should do that. The LCM of 2, 3, and 1 is 6. Or let's say 2 and 3, because 1 is not so much of a number to worry about though. So except when you are adding or subtracting. In multiplication and division, 1 is not a number to okay, that's by the way. So when we get that, we are going to use the LCM and multiply through. Okay, so we'll multiply through by the LCM. Multiply through by LCM. So the LCM is 6. So we are going to have 6 times x over 2. My marker better behave well. 6 times x over 2 plus 6 times y over 3 equals 6 times 3 over 1. Okay, 3 here is the same thing as 3 over 1. Okay, so 2 here is 1. 2 into 6 is 3. 3 times x gives us 3x. Plus 3 here is 1. 3 into 6 is 2. 2 times y gives us 2y. 6 times 3 gives us what? 18. Alright, so that's it. So we have 3x plus 2y equals 18. This becomes our number 1 equation. Okay, and then let's go to the other equation, the second one, where you have x plus y over 2 equals 5. Now we also are going to look for the LCM if you are asking that. Yes, we'll look for the LCM and multiply through. We want to clear this fraction that's here. Okay, so the LCM here is 2. So by the time we multiply through by the LCM, we have 2 times x over 1 plus 2 times y over 2 equals 2 times 5 over 1. Okay, 2 times x gives us 2x. 2 here cancels. We are left with what? Y alone. And 2 times 5 gives us what? 10. Okay, so these are the two equations that we are going to solve simultaneously. These are the two equations we are going to solve simultaneously. So I'm going to use this other part of the board. So we now have to solve 3x plus 2y equals 18, and 2x plus y equals 10. So in this problem, I'll not be using elimination method. Okay, I'll be using substitution method. Now, why am I using substitution method? Because I have a situation where the coefficient of one of the variable is 1. Like you see y here, the coefficient of y is 1. Okay, so I can easily make y the subject of the formula. So I have equation 1 here, and I have equation 2 here. So I can say from equation 2, okay, from equation 2, let's make y the subject of the formula. So y is going to be 10 minus 2x. Okay, what did I just do? Just move 2x across the equality sign to meet with 10. And of course, crossing the equality sign, it becomes a negative number. Okay, so with this now, I will then substitute it. Substitute into equation 1. Okay, so I'll substitute it into equation 1. Note that I cannot substitute it back into equation 2. If I substitute it back into equation 2, it gives me 0. It makes everything here to become 0. Okay, so I'll take over here again. You can, if you want to write this, you can just replay the video, go back to where this is, and the timeline, and then you have that done. Okay, so if I'm substituting into equation 1, that means my equation 1 will become 3x plus 2 instead of y. Since y is 10 minus 2x, I'm going to write this instead of the y. So I'm going to put that in a bracket because we have two terms there. 10 minus 2x equals what? 18. Okay, so you can see that now I'm left with x now. The y is no longer there. So I have 3x. I'll use the 2 to clear the bracket. Plus 2 times 10 will give me 20. Plus 2 times minus 2x will give me minus 4x equals 18. So what will I do next? I'll collect like terms. I'll collect like terms so that I'll have 3x minus 4x plus, equals 20 minus 8, equals 18 minus 20. Alright, so of course 18 is here like the landlord. So this guy coming over is going to take the negative sign and move the other way. Okay, 3x minus 4x is simply minus x. 18 minus 20 is minus 2. So with that said, or with that now, we divide through by minus 1. Okay, once we do that, this minus will cancel out. So we'll be left with x equals minus 2 divided by minus 1 is simply 2. Minus divided by minus is plus. 2 divided by 1 is 2. Okay, now with that said, let's now look for y. We need to find what our y is in this question. So if you look at it closely, we have that y is 10 minus 2x. So that means that y is going to be 10 minus 2x. X is 2, right? Okay, so I can say here that but x is equal to 2. So I'm going to have 2 into 2, right? Because x is 2. Okay, so I have y equals 10 minus 2 times 2, which is 4, right? 2 times 2, which is 4. So y is going to be 10 minus 4, which is what? 6. 10 minus 4, which is 6. Okay, I think I should write it here so that you just see. This semicolon is to separate what is here with what I'm going to write now. So this is going to be y equal to 10 minus 4 is what? 6. Okay, so that is how we solve this kind of problem. You see, we started by clearing the fraction, and then we now choose the method and we solve. Alright, so there's going to be another example on simultaneous equations in fractions. You see, this particular simultaneous equation is still in fraction, but contrary to the one we just did, you find out that the variables are the denominator. Okay, the variables are the denominators. So the question now becomes, how do we solve simultaneous equation problem like this? Okay, sorry, I'm going to do something. I want to change this to a negative sign, and this will become, write this as minus 1. I want to use a negative sign because we've been dealing with too many positive signs, right? So, okay, okay, that's it. So let's look at it. How do we solve a problem like this where the denominators are the variables? Simply, we do it this way. See what we're going to do. The normal routine of taking LCM, multiplying through and all that will not really help us solve this problem, okay? So what we do is, look at this. I'm going to write this as 2 into 1 over x right? Are you with me? Minus 4 into 1 over y equals minus 1. Alright? And I'm also going to have 6 here into 1 over x plus 8 into 1 over y equals 7. Okay, so these are now the variables I have. The variables are like are like reciprocals. Okay, they are like reciprocals. So I will call this. I'll call this equation 1, and I'll call this equation 2. Okay, call that equation 1. I'll call this equation 2. Now you see, this is still going to boil down to, I'm going to use elimination method here. I'll try to eliminate by making these numbers outside the bracket as standing like the coefficient, okay, of this what is inside the bracket. Okay, so how do I now make the coefficients to be the same so that I can eliminate? You know, in one example that we did, we had to use the coefficient here to multiply here, and then use the coefficient here to multiply here. Okay, but that's not what we are going to do in this case. Okay, it will still be okay if we do the same thing. Okay, use 2 multiply the whole of this, use 6 multiply the whole of this. It will still be okay if we do it that way, but we are not going to do it that way. Now look up, I'm just going to show you something else because well, okay, just look at what I'm going to do. I'll multiply equation 1 by 3. Okay, if I multiply equation 1, this is equation 1. If I multiply it by 3, I'm going to get 6 into 1 over x, right? Minus 3 times 4 will give me 12 into 1 over y equals 3 times minus 1 gives me what? Minus 3. Right? So you see that. Now, I'm not going to do anything to equation 2 because just by multiplying equation 1 by 3, I have been able to get the coefficient of equation 1, the coefficient of 1 over x in equation 1 to be the same with 1 over x in equation 2. Alright, so I'm not going to do anything to equation 2. Okay, so you see that. So at this point, the simple thing I'm going to do is to do my subtraction to eliminate. Of course, subtraction is what will work here. So this whole thing here, they are the same. Okay, so this minus this, they will just simply go away. And this minus this, minus 12 minus 8 is going to give me minus 20 into 1 over y. Yeah, that's what I'll get. Yeah, it will give me minus 20 into 1 over y. Then minus 3 minus 7 will give me minus 10. Will give me minus 10. You get that, right? So this will now simply mean that I have minus 20 into 1 over y equals minus 10. So I'll divide both sides. I'll divide both sides by minus 20. So if I divide both sides by minus 20, I'll have 1 over y by minus 20. I have 1 over y left because that minus 20 will take care of this guy. And I will be left minus 10 over minus 20. Okay, so the minus will cancel to become plus. 10 divided 0 will cancel. So that means that I think I can't go further down. That means that I'll have I'm coming this way now. That means I'm going to have 1 over y equals 1 over 2. So at this point in this fraction, all I'll just do is I'll cross multiply. Okay, I'm not sure. Okay, I'll cross multiply here. So I'll have y times 1 to be equal to 2 times 1. Y times 1 is y. 2 times 1 is 2. Y times 1 is y and 2 times 1 is 2. So y is equals to 2. So that's the solution for y in this problem. Okay. Now let's also look for x. Okay. Let's look for x. Now in this case now, remember we have been able to look for y. So we can just substitute for y in any of the equation or either of these equations. Okay. Remember we now have from this one. Okay, I'll call this from this equation 1. This is still equation 1. We have 2 over x minus 4 over y. Y is 2, so I'm going to write over 2 equals minus 1. Okay, so I have 2 over x minus 4 over 2. Minus 4 over 2 is minus 2. Okay, equals minus 1. You see that? So I'm going to have 2 over x. Is my camera covering that part? Yeah. 2 over x equals minus 1 plus 2. Okay, so now I can take down this side so that I can finish up what is here, right? So you can always replay it to get whatever it is that you may be missing. So you have 2 here, 2 over x here to be equals to minus 1 plus 2 is simply 1, right? Yeah, so this can be written as 1 over 1. So by the time I cross multiply, I'll have x times 1 to give me x, 2 times 1 to give me 2. 2 times 1 to give me 2. Alright, so this is simple. So that means y is 2, x is 2 in this question, and y is 2. You can often check that. If you put 2, the value of 2 for x here, put the value of 2 for y here, you're going to get this. Alright, so that's how this is solved. One way you can actually learn from what I'm showing you is every example I do, take it, try working it on your own. Okay, try working it out on your own, and wherever you encounter challenges, then you make reference to what I just did, and by that you'll be grounded. And whenever you see any other thing that looks like this, you should be able to, deal with it squarely. All right, hope you're enjoying yourself.